Hi all. We've been looking at radicals the last few videos that I've been making. Let's take a look at what happens when it comes to graphing radicals, square roots in particular in this video. So I'm going to show transformations here. Let's do the square root. F of x equals the square root of x first. Okay, so first we need to figure out, let's put a little table together. I'm only going to do the table this one time because frankly, I hate doing these with tables because there is a faster way, and I'll show you that way. So 0, 1. What I'm looking here for my x values, by the way, are perfect squares. The square root of 0 is 0. Square root of 1 is 1. I'm not going to put a 2 down for x because the square root of 2 is going to be irrational. But I will use 4. The square root of 4 is 2. And I'll use 9. Square root of 9 is 3. That ought to be plenty. So I'll put 0, 0. 1, 1, 4, 2, and then 9, 3 is going to be out here somewhere. So my graph's going to look like this. Looks kind of like an eyebrow, right? Unless you have a unibrow like Brooke Shields. Oh, did I just say that? Shoot, some of you guys probably don't even know who she is. All right, so let's take a look at g of x equals the square root of x minus 1. And you know what? My apologies, Brooke. You're a beautiful woman. The square root of x minus 1. So what's that going to do to my graph here? Okay, I talked about transformations before, I believe. But just to play it safe, let's see what would have happened if I did x minus 1. So I'll use the same values for my x. 0, 1, 4, and 9. And let's see what that does. That's going to give me problems is what it's going to do. So if I use 0 here, that's not going to work out, is it? 0 minus 1 is a negative 1, and I'm going to be trying to take the square root of a negative number, so that's not going to play out for me. So I've got to think this one through a little more if I want to do this chart business. So let me try 1. If x is 1, 1 minus 1 is 0. The square root of 0 is 0, right? Now let me try a 2 for x. 2 minus 1 is 1. The square root of 1 is 1. So you see the pattern what's happening here. Looks like my x value is going up 1, huh? So let me keep playing to that. Instead of 4, let's try a 5. 5 minus 1 is 4. Square root of 4 is 2. So it looks like my x value is going up 1. So let's look at this guy. My 9, we're changing it to 10, right? 10 minus 1 is 9. Square root of 9 is 3. So my x values are going up one value. Let's plot these guys now and see what's happening. I'm going to plot 1, 0, 2, 1, and then 5, 2. See what's happening there? My graph is shifting 1 unit to the right, correct? Which coincides with what's been happening with my x values. In order to make this thing work for me, I had to increase my x values by 1 unit in order to come up with nice perfect squares there. So because I'm increasing my x values by 1 unit, it's making my graph move to the right one place. Now you would think that when you look at this, you say, oh, x minus 1. The minus 1 means go to the left 1 unit. No. Okay, it's kind of the opposite of what you would think. So if you see an x minus 1, it means, or x minus whatever, it means move to the right, okay? That minus is going to mean move your graph to the right, however many units you need to here. So let's look at this h of x. I'm not going to use a table this time. Hopefully you're going to see what's about to happen. It's a square root of x plus 1. Which direction is it going to move my blue graph there? If you said to the left, you are correct. It's going to move everything to the left one place. Okay? Well then, what about this j of x? The square root of x plus 1. Okay, that is going to move my entire graph up 1 unit. So my blue graph is going to start here, and it moves up. So what about this square root of x minus 1 for my k of x? If you guess it's going to move it down, then you would be correct. Okay, so that's a fast way of graphing these. If you see action going on inside the radical, it's the opposite of what you would think. So x minus 1, it moves to the right, x plus 1 moves it to the left. And if you see action going on outside of the radical, then it's exactly what you would think. If it's plus 1, it goes up. If it's minus 1, it goes down. Okay, or whatever your units would be there. So that's a quick intro on how transformations work for radicals. This transformation idea, it's going to be the same for pretty much anything. It'll work for absolute values. It'll work for quadratics, cube roots, cubes, logarithms, exponential functions, parabolas, you name it. The same principle will apply. And as time goes on, if you keep watching my videos, you'll see this come into play over and over again.